Hello guys, welcome to the stream. We will be starting it soon. Let's gather some viewers right now. Okay. Join in on the stream, guys. I should open my Visual Studio. Well, hello guys. Today we will be discussing about decision making and loops. I'm also going to teach you about some basic operators today. Actually, we should have covered the operators first, but let's do it now. Let me put my device in priority mode. Okay, so today we are going to learn about some basic operators. Decision making and then loops. So basically, in operators we're going to cover all the operators that we are going to use in order to perform various mathematical, logical, and bitwise operations in Python programming language. This includes plus, minus, addition, subtraction, multiplication, logical and, or, and stuffs like those. Also relational operators such as greater than, less than. In decision making, uh, we take a look at if statements, and there's no switch statement in Python. So it's just if and else. Then in loops we're going to cover, for, and while loops. So let's get started, guys. Now, yeah, let us first cover some basic operators and some operations to perform in Python. Okay, I have opened up the code editor and also the terminal in here. Okay, so you can do that. Okay, I've opened up the interpreter. Now let's see what are the basic operations that we can perform. First of all, the basic operations. In basic operations, let us first discuss about uh, yeah, arithmetic operations, right? That includes plus, minus, and stuff like those. Division, addition, subtraction, division, multiplication, modular division, which is done by this, and also this. Now we will discuss about those in details now. Arithmetic operators. Let us okay. Let me do a comma b equals to 5 comma 4. So I've assigned 5 to a and the value 4 to b, variable b. We've created two variables, and we have used multiple assignment, just like we discussed in part 2. Oh, sorry, part 1. Now let me do perform addition of a and b. If I print c, then it's going to be 9 because it's addition operation. If I do a minus b, then it's going to be 1 because 5 minus 4 gives 1. It performs subtraction. If I do a asterisk b and print c, then it gives us 20 because 5 times 4 gives 20. So it's multiplication. Now if I do a divided by b, the answer should be in float, which is decimal, yeah, decimal points, 1.25. This performs division. Now we are going to perform modulus operation. What is a modulus operation? Well, a modulus operation returns the remainder. At first it divides the left hand operand by right hand operand and then returns the remainder. Let's see. Sorry, percent a, it gives us 4. That's it. It gives us the remainder. Now the next thing that we need to do is something called exponential operator. So what is an exponential operator? In Python we represent it by 2 asterisk. So single for multiplication, double for exponent. It is basically the operation in which the variable or the value gets raised to the power Like for example, if I want to do a square, then I do this, a to the power 2. If I do a to the power 5, then I simply do this, and we will get the result in C. If I print C, we can see that the power of the a has been raised by 5 times. A to the power 5 gives 3125, as we have stored the variable 5 in variable a. Okay, so in easy terms, exponential operation performs the operation of raising the power of a variable by specified value. We could also do it in this way. So let me suppose a equals to 2 and b equals to 5. Now c equals to b. It's going to return the value of 5 square to the variable of c, to the variable c, because in b we have stored 5 in the left hand operand. Left hand operand stores 5 and the right hand operand stores 2. So 5 to the power 2 gives us 10. Let's print C. Oh, sorry, 25. I don't know what I was thinking. 5 5 is 25. And we get the answer 25. Okay. Now the next thing that next operation is called something called floor division. It is represented by two division, uh, you know, two division operator sign, double slash. So what the floor division does is, uh, first of all, it rounds off the value. The division of operands where the result is the quotient in which the digits after the decimal point are removed. Let's take a look. For example, if b equals to, now if I divide by 4, now if I do, it gives us 0. So it gives us the quotient, right? What if I do b? It gives us 2, because this is the quotient. Well, the British gamer, yeah, I know. C++ is a great language and has a good hardware. I mean, and it can be used in hardware level very easily, and it is very fast than Python. But Python is easy to use, so it's more interesting, and also it's very beginner friendly. So we don't have to, you know, take care of a lot of stuff in which we have to do in C++, for example, memory management and stuff like those. In Python, you just type the code, which is relatively easy, and you run it as a scripting language. So yeah. Now what we need to do next is, let's see, modulus, right? Let's say b holds the value of 20 and a holds the value of 10. If I perform a modulus operation, then it returns the remainder 0, because you know, because there is no remainder. 20 is completely divisible by 10. So we get no remainder and thus the answer is 0. Let's see what we get if we do, if we perform a floor division. We get 2 because 5 divided by 8 gives 2 and the quotient is 2. I hope you are clear on this. Let's okay, when I animate there is an option to enable Python scripts, if you know what that means. Well, you know, Python is like a scripting language, and scripting language are generally easy to write and flexible. So you can use such scripts to automate a lot of stuff. For example, when you animate stuff, maybe you can write some Python scripts on your own, so that you can automate some uh, things that you can do while animating. But I don't know much about animation, so yeah, I guess mainly they use Python scripts so that you can automate many stuff. You don't have to do those things by hand. You just run those scripts and it does those stuff for you. Now let's move on to another thing. Now what we just did are called arithmetic operations, and like we discussed, these contains addition, subtraction, multiplication, division, modulus, exponent, and floor division. Okay, now let's take a look at assignment operators. You know, these operators are used so that we can assign certain values to a variable, right? So we have already been using an assignment variable, which is equals to, this assigns a specified value into a variable. For example, c equals to 10, and if I print c, it prints 10 because we just assigned the value 10 to c. Now the next thing that we do is called, add and operator. Yeah, go on. I'm actually a Nepali, but since we are not native English speakers, our accent is like Indian. Yeah, you can say that. My accent is Indian. Yeah, you can say my accent is Indian, but I am not actually from India. Now, the next thing that we do is something called this operator. It's also an assignment operator, but we also perform an operation in this. Okay, let's do. Let's first do c equals to c plus 1. So what this statement does is, since we set the previous value of c to 10, it does 10 plus 1 and stores that value into c. If I execute this and print the value of c, yeah, oh, the British gamer, yeah, northern accents, okay, but I hope you don't have trouble understanding my English. Why are we getting result 11? Because we performed an operation 2. We just took the value of c, currently existing value of c, which is 10, and incremented it by 1 and stored that value into c. Now the c is going to hold the value of 11. Okay, British gamer. Yeah, you can come back if you like it. I'm a beginner though. Yeah. Now let's do something like this, but in another way. Okay. Now as I assigned the initial value of c to be 10, I am going to do c plus equals to 1. Let's see. It gives us 11. So what we did was shorten this shorten this assignment into. Hello Pratham. Yeah, we are learning about some operators today. Now, yeah, so as you can see, let me revise that again for you. C equals to C plus 1 and C plus equals to 1. They are identical. So what this statement does is it takes the initial value of C and it looks at the statement, the interpreter then looks at this operator, right? C plus, and then it does not look at this equals to, but it takes a look at the next value, which is this. Then it executes the statement c plus 1 and then stores the result in the variable c itself, and thus we get the result. Okay, let me do this in another variable. Let's say I've assigned d equals to 0, right? Now if I do d plus equals to 1, sorry, my mistake, then this should increment the value of d by 1. Yes. Likewise, I can also do d minus equals to 1 and it will decrement the value of d by 1. Now, this gives us um, something somewhat flexibility. We can write something that takes this much in a short way. Again, doing this and doing this are same. But it's a shortcut way, right? And it's convenient too if you are using a single variable and want to store the value in the same variable. But if you want to do, then you must write, if you want to use two variables, then you must do it in this way. But if you are making some changes in the same variable using the value of same variable, then the shortcut method will be handy for you. Same goes for multiplication too, and also same goes for division, also for exponent. And that's it. We can do the same for floor division too. And the numbers could be any number. For example, I could do c plus equals to 5 or 5.10 or anything like that, and the change will be done. Let's see, I could do 0.5 and let's print the value of c. It's 14.5. Now let's look at the example one by one. Okay, let me make a variable a equals to 0. If I want to add 5 to this, and the value 5 is going to be added. If I want to decrement a certain value, let's say I want to decrease it by 3. Yes. If I want to multiply it by 2, and in the value of a it's going to be 4, because 2 times 2 times 2 times 2 is going to be 4, and it's going to be stored in the same variable. That's why when I print the value of a, the interpreter gives me the result of 4. Now the next thing, let's perform division by 4. If I print the value of a, it's 1, because 4 divided by 4 gives us 1. Now since the value of a is 1 right now, let me do a equals to 2, so that you can look at the change that I do. A equals to 2. I've assigned a new value to a, so the value of a is 2 right now. Now if I perform exponential operation but with the assignment operator, and I want to raise the power of 2 by 2, okay, this should give us 4, because 2 to the power 2, which is 2 square, gives us 4, and it's stored in the variable a. That's why when I print the value of a, it returns 4. Now the next thing is called floor. Let's do that too. Something called floor division, right? A equals to let's say 3. If I print the value of a, it gives 1. The quotient is 1. It does not give us any sort of remainder. Now if I do modulus, it's going to return us the remainder and store the remainder in the same variable. Let's say modulus, it gives us remainder of 1, because 1 is the remainder when 1 gets divided by 2. So now you can involve other variables in this situation too. For example, if I want to do a equals to a plus b, then it's a simple thing, right? A equals to a plus b, so a equals to 1, b equals to 1. Sorry, you can assign in such a way too. Now let me print the value of a and b. They are both 1. If I want to perform a equals to a plus b, then instead of writing the whole thing, I can do a plus equals to b, and the value of a is going to be 2. And the same applies for all the other assignment operators that I showed to you. Now the next thing that we are going to cover is something called comparison operators. And comparison operators means that these operators are used to compare the values and either return true or false. And again, let me tell you, true and false are a type of data type. They are a data type, and they are called booleans. They represent 0 and 1, 0 for false and 1 for true. And the comparison operators are used in order to compare the values or certain condition of two variables and return either true or false. If the condition is met, it returns true. If the condition does not satisfy, it returns false, right? For example, some of the basic comparison operators are this: equals to, not equals to, this is also not equals to, greater than, less than, and and then greater than or equal to, less than and equal to. Now let us discuss this a little bit further one by one. Now let's just discuss equals to first. Let me say 5 equals to 5 um, is equal to, right? This represents is equal to. So by that logic, we are checking whether the value of the left hand side is equal to right hand side. And by logic, we can say that 5 is equal to 5 actually. So this should return true. True, right? 5, 4. Do you think 5 is equal to 4? Obviously not. So it should return us false, right? That's the basic concept. You can, all you can do is store some value in 5. Store some value in a variable. Compare those values. Let's say a equals to 6. Is a equals to 6? False, because the value of 5 has been stored in a. That's a good stream. Yamos. And b equals to 5 should return us true, because the value of b is indeed 5. Yeah. Now with the same concept, let's say, now remember that the value of a and b have been set to 5, right? Now with the same concept, let us say discuss about not equals to. Is b not equals to 5? Let's think this again. The value of b is 5. Is 5 not equals to 5? What should this return? This should return false. Why? Let me explain. Because 5 is obviously not sorry, 5 is obviously equals to 5, and the condition we are checking for is not equals to. And this statement is telling us that 5 is not equals to 5, which is absurd and totally false. That's why we get false as a result. It's like but it gives us true, because 4 is not equals to 5, which is true. The concept is clear. The interpreter is going to check whether the whole statement makes sense. I mean, if the whole statement is true, then it will give us the result true. Let's say a is not equals to 5. It is going to return us false, because a is equals to 5. Let's say a is not equals to 8. Then it is going to give us true, because we have stored the value of 5 into variable a. So 5 is not equals to 8, right? And this statement is true. Now like we have studied in mathematics, this sign represents greater than and this sign represents less than. So let's say 8 is greater than 9. 8 is greater than 9. Is this statement true? No, it's false. That's why it gives false. But 9 is greater than 8. That's why it's going to return us true. So it's comparing which is greater. Also, let's see. Generally these operators are going to be used in if statements. So similarly, for less than, 8 is less than 9, true, but 9 is not less than 8. Is 9 less than 8? It's going to return us false. Is a greater than b? Remember that both variables have 5, the value 5 stored in them, but is 5 greater than 5? What will this return? This is going to return as false, because A is equals to B. A is not greater than B. 5 is equals to 5, and 5 is not greater than 5 because 5 is equals to 5. That makes sense. Now if I increment the value of A by 1, and now let us compare A is greater than B, it's going to return us true because the value of A is going to be 6, and 6 is indeed greater than 5. Yeah. The next operator is called greater than or equal to. Its concept is also clear. Greater than or equal to. Let's compare it now. No, let's use some raw values here. Let's say 5 is greater than or equals to 5. Well, let us read the statement again. 5 is greater than or equals to 5. Now this statement is partially true and partially false, right? Because 5 is not greater than 5, but it is equals to 5. So we are saying or, right? Greater than or equals to. So since or comes into the statement, then it means it has two conditions, and the statement becomes true even if only one condition is truthful. So 5 is not greater than 5, but it is indeed equals to 5. That's why this returns as true. Now let's say 6 is greater than or equals to 5. Let's check that statement. 6 is greater than 5, but it is not equals to 5. But 6 is greater than 5. So among the two conditions, one condition has matched. That's why the statement is true. But let's say 4 is greater than or equals to 5. Okay, 4 is greater than or is greater than 5. No, 4 is smaller than 5, less than 5, right? Is 4 equals to 5? No, 4 is not equals to 5. This means both the conditions have failed. So neither is 4 greater than 5, nor is 4 equals to 5. That's why the statement is obviously false. I hope this clears up your concept regarding greater than and equals to. Let me say it's the same for less than and equal to. Let's say 5 is less than and equals to 5. Here only one statement is true. That is 5 is equal to 5. And 5 is not less than equal to 5. The statement is false because the statement 5 is less than 5 returns false. But statement 5 is equal to 5 returns as true. That's why one condition has been met and the result should be true. Now let's say 4 is less than and equals to 5. Here 4 is not equals to 5, but 4 is less than 5. The statement is true, hence the result should be true. Now 6 is less than or equal to 5. 6 is not equal to 5 and 6 is greater than 5, which means this statement should return the result false. Yeah. Well, that's the essence. Now we know about greater than, less than. Okay, let's see. Now after this, so we have complete knowledge of equals to. is not exclamation and equal to, which means not equals to, greater than, less than, and greater than or equal to, and less than or equal to, and then there's another statement, sorry, and there's another operator which is also called not equals to, or instead of this it can be written as this. Let us discuss that a little bit. 6 5 okay, sorry, but this is something that's supported in Python 2, I guess. But just to give you a concept, it's going to give an error in Python 3, and the support for this also has been stopped, I guess. But in Python new, if you are using Python 2, then this is also going to return, this is also going to work as an not equals to, because it is neither greater than nor less than, and it is also not equals to, it also does not come between these two categories, so it returns us false if both the values are not true, or values are not equal, sorry, not equals to. Now let's move on to another other stuff. For example, we've completed we've completed arithmetic operators, which are plus, minus, multiplication, divisions, and stuff like those. We've covered assignment operators, you know, and then we covered logical or comparison, sorry, we covered comparison operators, greater than, less than, and stuff like those. Now we're going to do something called logical operators, and like the name states, these rely on logic. Let's have a look. They are and, or, and not. Okay, let's see. Let me let me discuss about and statement first. Okay, in and, there are generally two conditions, only two conditions. We are comparing two conditions in this. Okay, because and is a binary operator, it requires two values to get compared with, and when and comes in a statement, both the conditions have to be true. Let's say 5 equals to 5 and 6 is greater than 5, is going to return us true. But let's say 5 is going to return us false. Why? Because in and, both the conditions have to be true in order for the final result to be true. And right, true and true gives true, else it gives false. If any of the condition returns false, then the whole result tends to be false. It always has to be 1 and 1, or it's going to return false. Let's do this. 5 equals to 5 and 6 is greater than 4. Okay, let's do this in a raw way. Pre true and true returns true. True and false is going to return false. False and false is going to return false. False and true is going to return false. Well, from the above example, you can see that the AND operator returns the value true only if both the conditions are true. If any of the conditions are false, it gives the result as a false. And if both the conditions are false, then obviously it's going to be false. Now let's move on towards OR operator. It's a simple operator and we've used it before to define when we were discussing about the uh, comparison operators, like greater than or equals to, right? True or true gives us true. That's logical because both the statements are true. Now for OR, in case of OR, it returns true even when only one condition is met. Like, you know 5 is greater than or equals to 6. Here there are two conditions in this statement. Either 5 is equals to 6 or either 5 is greater than 6. Here the condition 5 is equals to 6 is false, but the condition 5 is greater than or equals to, sorry, I gave the wrong example. But also you can see the 5 is greater than and 6 is also false. Hence it returned us false, right? Let's say 5 is less than and equals to 6. It gave us true because 5 is not equals to 6, but 5 is less than 6. So among the two conditions, one condition has been met. Thus it has returned us the value true. Just well, it's the same thing, you know. False or true will give us true, right? And true or false will give us true. The OR is going to return false only when both the condition are false or false. Okay, my typing mistake. Okay, now not. Well, not is like it inverts everything. Not true is going to return as false. It changes the result of the statement. For example, let's say 5 is equals to 5, right? The statement is true, but since we have not, it's going to return as false because 5 is not equals to 5. This statement generally means that 5 is not equals to 5, but 5 is equals to, but in reality 5 is equals to 5. That's why we get false. The not inverts everything. It's like this, right? So let's say not 5 is equals to 5 and 6 is greater than 5. Here 5 is equals to 5 gives us true, and 6 is greater than 5 also gives us true because 5 is equals to 5 and 6 is greater than 5. And the final result should be true because it's and for the condition and for the AND operator, both the conditions require to be true. Hence they give the result true, but we have not. That's why not true means false. We got false. Well, that's all there is about logical operators. discuss and, or, and not. Okay, now there is something called in operator. There are membership operators, right? Membership operators and not in. It's something new. And if you come two membership operators, and those are in and not in. Let me define a list. 1 2 3 4 5. Okay, I typed it incorrectly and made it lost, but it's okay. So let me check a condition. 5 in lost. Well, what I'm saying is, does the value 5 exist in lost? It's going to return us true, because 5 does exist in lost. We have used the in operator in this, right? Let's say 6 in lost. It's going to return us false, because 6 does not exist in lost. Similarly, I can do this in another way. Let's say 6 not in lost. Well, this statement tells us that 6 is not in lost. Now we have to check that, right? Let's see. 1 2 3 4 5, and 6. There exists no 6 inside this list. Again, I have discussed about lists in part 2. You can go there and watch it. I've also described it at the end of part 1. Well, hello, Joe and Jos. So, since there exists no 6 inside this list, here it's going to be true, because 6 is not in list. True. Let's say 5 not in list, then it's going to return us false, because 5 is in lost, but 6 is not in lost. We can do these things with tuples, right? And lists. You can do this. Maybe you can do this also in dictionaries. I don't know, but we can also do this in strings. For example, let's say name equals to Thomas. Let's say okay, that's a weird name, but okay. Let me check whether the alphabet J, the character J, exists in name or not. J in name. Sorry. String characters should always be written inside double quotation marks, otherwise you are going to get errors. J in name, it returns us true because there's J in name. Let's check John in name. It is also going to return us true, because the characters John are indeed inside the string name, right? Let's say J in name. This should return us false, because it's case sensitive. This is small j and it's capital J. So, well, you should be careful about using this, because it is also case sensitive in case of strings. Now we have finished not in and in. There is something called operator precedence, but you can check that later on. We will discuss about it later on. But operator precedence means which operator takes precedence before, which operator takes the most priority. Let's say 5 plus 5 divided by 6. Now you know the BODMAS rule. First the operation inside brackets get executed, then only the outer operation takes place. Yes, 10 divided by 6. Yeah. Now we should move towards something called loops and decision making. I think this is going to go a little bit farther than we expected, but that was all for today. We have exceeded our 1 hour limit each day, but tomorrow we will be discussing about decision making. This means if else statements, and hopefully we will also learn to make our own version of switch case statement, since switch case statement is not provided by Python by default. So thank you for watching my stream, guys, and please like and subscribe if you liked it, and we will be continuing this series tomorrow with decision making. Okay, peace.